Okay, now we're on page 2 of Monday's lesson. This says a rowing team with the current helping. Right away I'm going to write the with the current speed would be R plus W. Traveled 18 miles in 2 hours. Well, that's an easy enough equation. 2 hours times speed R plus W equals 18 miles. Second sentence says, against the current, they went 8 miles in the same amount of time. So same amount of time means we use 2 hours again. Against the current, there is the R minus W to represent the speed. And what's the distance there? 8 miles. Okay. Well, now the important division step. Divide both sides of this by 2. Write that down. Divide by 2. And we get just plain old R plus W equals 18 divided by 2 is 9. And the second equation, again, since it's a multiplier, 2, we divide by 2, and we get R minus W equals 8 divided by 2 is 4. And now we are ready to add columns because you see once again we have opposites in the W column. 1R plus 1R makes 2R, cancel, equals 13. And divide both sides by 2, and we get 6.5, 6.5 miles an hour. That's the speed of the rowing team. So I'm going to say rowers, 6.5 miles per hour. And then to get the speed of the current, I'll write R plus W equals 9. I'll replace the R with the 6.5. Let me do that over here. 6.5 plus W equals 9. Subtracting 6.5 from both sides, we get the W by itself, and that'll be 2.5. So the water speed, or the speed of the current, 2.5 miles per hour. Okay. That's number 4. Number 5. An unladen swallow can fly 26 miles to a food source with the wind in 0.2 hour. That's 2/10 of an hour. So there's the time. 0.2 times the speed. Now that's with the wind. So R plus W. The distance was 26 miles. Now, reading on, return trip, it could only travel 16 miles in the same amount of time. So same amount of time means it's 2/10 of an hour again. Against the wind, we use R minus W for the speed, and it was only able to go 16 miles on the return trip. It didn't get all the way back where it started, I guess you could say. So, be careful here now. We're going to divide by 2/10. 2/10. So I punch in 26 divided by 0.2, and I get 130. So dividing by 2/10, that'll erase the 2/10 and the parentheses, and we'll have R plus W is 130. And the same thing here, same step I should say, divide by 2/10, and that'll leave us with R minus W as 16 divided by 2/10 is 80. Let me double check that. I didn't do it in my head. Yeah. Okay. So adding the columns, 1R and 1R, that's 2R. W's cancel. 130 and 80 is 210. And divide by 2. R is an incredible 105 miles an hour. That's a fast bird. So I'll write bird, because that's less letters than swallow, and I'm lazy. 105 miles per hour. And then using that information in this equation, instead of r plus w, if I write 105 plus w equals 130, and take away 105 from both sides, then I'll have w equals 25. So the wind, 25 miles per hour. There's an answer for that. Okay. This one's a little different. With the wind, quarterback passes a football 140 feet in 2 seconds. So it's still like travel, and it's still rate times time equals distance, except it's feet and seconds instead of miles an hour. Oh, with the wind helping, here's the speed of the football with no wind. There's the speed of the football with the wind helping. 2 seconds times that speed got him 140 feet. Against the wind, that's that speed. Same pass would have gone 80 feet in 2 seconds. 2 seconds again, this time only 80 feet distance. So divide both sides of this by 2. You get r plus w is 70. 140 divided by 2, 70. Divide both sides of this by 2. We get r minus w equals 80 divided by 2 is 40. And I think you may be getting used to this by now. 1r and 1r, that's 2r. The w's cancel. 70 and 40 is 110. Divide by 2. And we get the rate is 55, and that would be feet per second. Okay, so the ball, use whatever word you want, but I'm going to say the ball for the football in still air, 55 feet per second. And then I can take the 55 and use it for r in any of the 4 equations, and I choose this one that looks like the easiest place to replace the r. 55 plus w equals 70, and if we take away 55 from both sides, I'm going to get w equals 15. So, wind, 15 feet per second. There's the answer for number 6. And now we're up to number 7 on page 2. Exceptional swimmer went 9 miles down the river in 3 hours. Down the river, remember we talked about this weeks ago, that means with the current. So there's the distance, there's the time multiplying the speed down the river, that's with the current, 9 miles distance. Attempting to swim back to the starting point, she only traveled 3 miles in the same amount of time. So the same amount of time, we used 3 hours again. Against the current, r minus w, or up the river, only went 3 miles. And do the usual stuff, get rid of the parentheses. In both cases, we're going to divide by 3. So we'll have r plus w equals 9 divided by 3 is 3. And we'll also have r minus w equals 3 divided by 3 is 1. And then we add 1r and 1r is 2r equals 4. Divide by 2. So this person swims 2 miles an hour in still water. Swimmer 2 miles per hour. And the current, if I put a 2 in there for R, it's going to say 2 plus W equals 3. So W obviously is 1. So the speed of the water, speed of the current is 1 mile an hour. Okay. That's the end of page 2. Next video, we'll cover page 3. Bye-bye.